The one on the test that a lot of people messed up, I think it was -7 squared minus the quantity of -7 squared. Okay. Here's the question for you guys. Is -7 squared the same thing as the quantity of -7 squared? No, it is not. -7 squared inside the parenthesis is what kind of number? Or what does that -7 squared mean inside the quantity? That means I'm going to take -7 and times it by -7, right? And what's -7 times -7? A positive 49, right? So this here is a positive 49. So we're subtracting 49 here. What does -7 squared without the quantity mean? I'm just squaring what number? 7. And then it's going to be negative in the front, right? So we're taking -1 times 7 times 7. And what's 7 times -1? -49. Okay, so it is different inside the parentheses compared to outside the parentheses. So what is a -49 minus 49? -98. A lot of people put 0 on your test. Okay, make sure you know the difference between these two. And I know we've talked about that a little bit before. Okay, you guys know why that's different. Okay, especially I like looking at it at variables. Like if I have negative x squared and the quantity of -x squared. Okay, when you look at it in this sense, -x squared, what's the coefficient here? What is the coefficient here? -1, right? That's the same idea, even if that x is a 7, not a variable. Okay, so make sure you know the difference with that. Okay, now as we look at these exponents, this 5 to the 4th power, what is 5 known as? Constant. It's actually known as our base. Our base. Okay. So if I say the same base, that big number has to be the same, or the same letter, or the same variable. Okay. The 4 is known as the exponent. And then 5 to the 4th is known as what? If I look at it as a whole, it's known as a, anyone know? It starts with a P. How would I say 5 to the 4th power? So the whole thing is actually the power. Okay. Is okay with that? All right, the exponential form is like 5 to the 4th power. Okay, which what does that actually mean? 5 times 5 times 5 times 5. So the exponential form is the actual exponent form. Okay. All right. So if I give you, write each expression in exponential form. Could you write that as an exponent? Does it say to solve it? No. Just write it as an exponent. So 6 times 6 times 6 times 6 would be 6 to the 4th power. Okay. This, the 5 times 5 times 5 times 5, the 6 is that's expanded form. Expanded form. Okay. All right. Now looking at B is a little bit different because we have coefficients, don't we? And are my coefficients the same number? No. So can I put an exponent with those? No. But could I multiply those? Yeah. What is -2 times 3? -6. Now, when I have PQ, what does PQ actually mean? P times Q. So we have P times Q times P times Q times P. We have some that are the same, don't we? Yeah. We have how many P's? 3. So it's going to be P cubed times Q to the 2nd power. And then do I need to have times in between between all of those? No. So this would be exponential form. Negative 6p cubed q squared. Blah. Okay. Any questions with that? All right. Find the area of a rectangle. Can we do that? Yeah, we should be able to. Because how do we find the area of a rectangle? Length times width equals. So what is my length here? 3x, so 3 times x, times what is my width? X. So 3, I don't have anything the same, right? So we leave it. And what's x times x? X to the second power. So my area is just 3x squared. Now, if I tell you now the length is, or the x is 12, could you figure that out? Yeah, we could plug it in, right? Which is what we'll do here in a little bit. Okay. One thing I have to remind you, is 2y cubed equal to the quantity of 2y cubed? No. Why not? What does 2y cubed, the first part of that, mean? Y is being cubed, so that just means 2 times y times y times y. What does the quantity of 2y cubed mean? Right, 2y is being cubed, so that would be 2y times 2y times 2y. Are those equal to each other? No, because 2 times y times y times y is just this 2y cubed. But what is 2y times 2y times 2y? 8y to the what power? Third power. So are those equal to each other? No. So make sure that, remember, that quantity is a huge difference in this. Okay. Go ahead and simplify these for me. Negative 3 to the 4th and the quantity of negative 3 to the 4th. Are these going to be the same answer? No. Okay. Am, right away. Huh? It's on the board too. Okay. Right. Thank you. So, do you think A is going to be a positive or negative answer? It's going to be negative. Is C going to be positive or negative? It's going to be positive because we have an even number of negatives, right? Yeah. Okay. Remember, A means like negative 1 times 3 times 3 times 3 times 3, whereas C means I'm taking negative 3 times negative 3 times negative 3 times negative 3. Now, here's the easy way to do this. What's 3 times 3? 9. What's 3 times 3? 9. And 9 times 9? 81. And what's 81 times negative 1? Negative 89. Instead of how many of you guys tried to do 3 times 3 is 9, times 3 is 27, and then you had to take 27 times 3, right? Isn't that a little bit harder than just doing 9 times 9? Yeah, remember, multiplication is commutative, so does it matter the order you multiply in? No, it does not. Okay. All right, and then what would I get for C? Positive 81. Because negative and a negative make a positive 9, so we get a positive 81. Okay. All right, B and D. What's different between B and D? Yeah, so when I was making copies, guys, so you know, I didn't hit the back, so that's why it's stapled. I didn't hit 2 to 2. Some of you might have it. Okay. What's different between B and D now? The parenthesis, yes, is different. Okay, but in B, I have to do what's inside the parenthesis before I do the exponent, right? Where in D, I have to do the exponent first, right? All right, so what's 1 plus 5? 6. 6 squared, is it 12? No, it is 36. Good. because 6 times 6. All right, now D, I'm not going to do 1 plus 5, am I? No, I'm going to do what first? 5 squared is 25, and what's 1 plus 25? Good. Now, what if I had something like 2 times 3 to the 3rd power? Would I do the 2 times 3 first? No, I still do the 3 cubed, which is 27, and then I would do 27 times 2, which is 54. You're on a roll today. All right. Evaluate. What does evaluate? Solve. Mainly plug in and simplify it, right? All right. Now, when I see 2a, what does 2a mean? 2 times a. So I'm going to take 2 times whatever a is. And what's my a? 3. Plus my b, which is -2. And then I'm going to square it. So we're going to do inside the parenthesis first, right? So inside the parenthesis, am I going to do the multiplication or the addition first? Multiplication. What's 2 times 3? 6. And then what's 6 plus -2? 4. And now can I square 4? Yep. And what is 4 squared? 16. Good. You got one? Right. And then example 5 is the same idea. Evaluate the quantity of x minus y cubed over 2x plus y. So in this case, we're going to do everything in the numerator. We're going to get everything in the denominator. And then the last step would to do what? Divide. Wow, my words are not coming out today. Okay, so we're going to simplify the numerator, simplify the denominator, and then we'll divide both of those. Okay. And 2x again means 2 times, right? So what is replacing my x in this problem? 2. What is replacing my y? 5. All right, so let's work at the numerator first. In the numerator, am I going to do 2 minus 5 first, or am I going to take 5 cubed first? 2 minus 5, okay? What is 2 minus 5? -3 cubed. So I'm going to keep working in the numerator. So -3 cubed means -3 times a, -3 times a, -3. So we have 3 negatives. Is my answer going to be positive or negative? Negative, and we're going to get a -27. Good. Over. All right, my denominator. Am I going to multiply or add first? Multiply. So 2 times 2, 4. And what's 4 plus 5? 9. And now, what is -27 divided by 9? -3. Good. And there you go. All right, any questions with that? No. Do not, one of the biggest things, do not distribute that exponent inside that. Always do what's inside the parenthesis first before you cube it, okay? This is not the same as that, okay? It is not the same. All right, is there any questions on 4.1? No, okay. So that's the assignment you were going to do before PSATs. You're reminding me about PSATs. Those at home, you guys, it doesn't include all of this. Okay, so I want to make sure we incorporate all of it so that you understand. Did you not guys that pick up the second copy? Anyone else? All right, so a monomial, okay? A monomial can be a number. Monomial can be a number. So give me a number. 3. 3 is a monomial. Okay? It's also known as what? An integer, yeah, it's a constant, right? Which is an integer, a natural number, a whole number, a real number. It could be a variable. What's a variable again? X. Could be Y. Could be A. The one that we don't like to use is I's. We don't use I's and we don't use O's. Those are the main ones we don't use because O's look like zeros and I represents imaginary numbers. Okay, so try not to use those ones. Or is the product of a number and one or more variables with the same exponents. All right. Actually, same positive exponents. That's the main word I wanted to look for, positive exponents. We haven't learned negative exponents, only positive exponents. Okay, so let me ask you, what's product mean? Answer to a multiplication problem. So is 2x a monomial? Yeah. Is 3y? Yeah. Is 7xy? Hmm? Is a negative 4x squared y? Yeah. Is there any that's not a monomial? When you start adding this to it? Yeah. So like if I have 2x plus 5, if I look at this, can I add those? No, they're not like terms, right? Are these monomials? No. How many monomials are within this problem? There are 2. We have 2 monomials. We have 2x and we have 5. So the plus or minus kind of separates the monomials. Since there are 2 monomials here, guys, this is actually known as a binomial. Yeah, which is lower problem there, you'll find out. So if there's 2 terms, 2 monomials, more specifically, then it's kind of a binomial. Okay, so I'm going to go ahead and scroll down since we kind of talked about that. So a binomial is a polynomial with 2 terms or 2 monomials, right? Terms are monomials. Okay, so would 9x squared plus 3x be a binomial? Yeah, okay, because they're not like terms, right? What about 7x minus 5y? Is that a binomial? Yes. Okay. Is 9x minus 2x? No, why not, Ryan? Because they're same terms. So what is 9x minus 2x? 7x. So actually it simplifies to a monomial. Okay. All right. Trinomial. What do you think a trinomial would be then? 3 terms. So we could have like 9x squared minus 4x plus 7. We have 3 terms. That's a trinomial. Now, anything 4 and above, we don't have specific names for that. We just call that a polynomial, okay? So a polynomial is one or a sum of monomials. One or more. I don't know why. I don't know. Or a. I don't like a. Or the sum of monomials. So main thing with poly means more than one, right? Now, technically a monomial is a polynomial. A binomial is a polynomial. A trinomial is a polynomial. 4 terms is a polynomial. That's the name for all of them, but we can get more specifically with monomial, binomial, trinomial, that kind of stuff, okay? So when I say we're learning to add and subtract polynomials, we could be adding and subtracting monomials. We could be adding and subtracting binomials, trinomials, but we're adding them all, okay, as general. So polynomial could be 5. It could be 7x plus 2. It could be 9x squared minus 3x minus 6. But we could make these more specifically, couldn't we? We could call them more specific. Okay. We could do, let's say 9x cubed minus 4x squared minus 7x plus 2. This one here is just called a polynomial. We can't get more specific. Okay. All right, does that make sense with that? All right, now, to find a degree of a monomial, okay, the degree of a monomial, it is the sum of the exponents of the variables. Okay, in a monomial. So, how do I find the degree of a monomial? You ask yourself, how many variables are there in total? Okay, so if I look at 3x squared, if I put that in expanded form, that means what? 3 times x times x. So how many variables do we have? 2. So the degree is 2. Okay. If I look at 5x squared y to the 5th, the constants mean nothing, or the coefficients mean nothing, but we have x times x, and we have 5 y's. So how many total variables do I have? 7. So my degree of that is 7. Okay. Does that make sense to you guys? All right. Let's go ahead and do example 1 here. Now again, do the numbers matter? Do the coefficients matter? No, it's just the variables. So how many variables do I have? Yes, ma'am. Yes, I'm sorry. Sorry about that. What's my degree in 5x squared? 2. What about negative 1/2 x y cubed? How many total variables do I have? 4. 8x cubed y cubed? 6. Negative 3? 0. We don't have a variable there, do we? And then what about 7c cubed d squared? 5. Good. All right. Any questions with that? All right. So these are the degree of a monomial. Now, degrees of polynomials are different. Okay. And again, what's a polynomial? We throw in what? Plus and minus signs. So like 7x cubed plus 4x squared minus 6x plus 7. Something like that. Okay. Just read them. All right. We can find the degree of each of these individually, couldn't we? Yeah. What's the degree of the first monomial? 3. Degree of the second? 2. Third and fourth? 0. So the degree of that whole thing together is the highest one. So the degree of the whole polynomial is just the highest degree. In this case, what's my highest degree? 3. So the degree of that is 3. Does that make sense? Okay. Standard form. Okay, if I want to write a polynomial in standard form, what it is, it's when the degrees decrease from left to right. So I'm going to tell you, I wrote this in standard form. Do you see how you degree with 3, 2, 1, 0? It's just you always put the highest exponent first down to the lowest. That's all the standard form is. Okay. When we write polynomials, they should always be in standard form. Okay. Which some of you guys were already doing that, so that was great. Okay. And then, what's a leading coefficient? What do you think? When I'm in standard form, so I'm in standard form here, what do you think my leading coefficient means? Peter? Yeah, it's the number in the front. Yeah, what's the number in the front? 7. So it's the coefficient of the first term. So 7 would be my leading coefficient there. Does that make sense? Just the number in the very front once you're in standard form. Okay. All right, example 2 here. Can you write each polynomial in standard form? Identify the degree of the polynomial and the leading coefficient. And then can we classify it by the number of terms? Yeah, if it's 1 term, it's monomial. 2 terms, binomial. 3 terms, trinomial. 4 terms and above, polynomial. Good. All right. So if I look at A, 15x minus x cubed plus 3, which one has the highest degree, highest exponent? The negative x cubed, right? So I'm going to put that first. So I have negative x cubed. What would be my next highest exponent? A positive 15x. So I'll put plus 15x. And then what's left? Plus 3. So this would be in standard form now. My degree, what's my highest exponent? Is it my degree 3? My highest exponent was 3. What's the leading coefficient? What is the number in front? What is the number in front here? Negative 1. Number, right? Number, not variable, number. And then classify my polynomial. Is this a monomial, binomial, trinomial, or polynomial? This is a trinomial. All right, let's do C together. Okay. Which one has my highest degree? Negative t cubed. So that one is going to go first. So negative t cubed. What would be my next one? T squared, is that positive or negative? Positive, so plus. And then what's my last one? Negative 10t, so minus 10t. So this would be standard form. My degree is my highest exponent. So what's the highest monomial degree? 3, yep. My leading coefficient is the number in front. What's the number in front? Negative 1. And then classify it. Is it a mon, bi, tri, or poly? It is a trinomial. Good. All right. Go ahead and try to do B and D on your own here. And D, that says 2.8x, right? 2.8x. Actually, I'm going to change D. So 2.8x plus x cubed minus, let's do minus 4x to the 5th plus 5. So this is your new D right here. So it changes it up a little bit. A few minutes. So what would be my standard form for B? Negative 9z plus 4, good. So that's standard form. What's my degree? 1, perfect. What is my leading coefficient? Negative 9. And what type of polynomial do we have? We have a binomial, perfect. All right, with my new D, what do we have here? What is my standard form? What would be my standard form for D? What has the highest exponent? Negative 4x to the fifth. Then what? X cubed, positive or negative? Positive. Then what? Plus 2.8x and positive 5. Good. What is my degree of this one? 5. What's my leading coefficient? Negative 4. And then what type of polynomial is it? It is a polynomial. Good. All right. Any questions with that? No? Pretty good. Awesome. Now, if we have, and when we talk about standard form, if there's multiple letters in there, there's no such thing as standard form. Standard form is when there's only one variable, just so you guys know. All right. So if we have x squared y in there, there's no standard form. You can put it in any order you want. Yes, sir. Huh? Right. Well, like standard form, if I have something like this, like if you're looking at 3x squared y plus 5 x y squared. Yeah, you'll always put like x before the y in that sense. But when you're looking at this, there's no standard form. And the reason being, because if you look at both of those monomials, what are my degrees? What are my degrees? 3 for each of them, right? So the degrees are the same. So there's not one that's higher, is it? So no, that's what I'm saying. Like standard form is just when there's one variable in that sense. So you could have 3x squared y plus 5xy squared, or you could have 5xy squared plus 3x squared y. It doesn't matter in that sense. Okay. All right. We do try to, when you list those monomials, yes, you do try to put the alphabetical order, put x before the y, but it really doesn't matter. Okay. Because multiplication is commutative, right? So does it matter the order you have it in? No, it does not. Okay. Now we're going to add and subtract these polynomials. To add and subtract, they have to be like terms, which we've already talked about this before, haven't we? Haven't we combined like terms before this year? Yeah, we have. When we learned the distributive property, okay? So what makes something a like term? Liam? Yeah, same exponent, same variable. So same degree, same variable, right? So like x, 2x and 4x. Negative 2x squared and negative 5x squared, right? Is 2xy and 4xy like terms? Yes, they are, right? Same variable, same exponent. Now, if I had 2x squared y and 5xy squared, are those like terms? No, because the exponents are different, right? With the x's and the y's, okay? And then again, we add or subtract the coefficients. And what do we do with the variables and the exponents? What's 2x plus 3x? 5x. We leave the variable and exponent the same. When subtracting, I always like to distribute the negative first. So you guys don't lose minus a positive, minus a negative. Distribute it and then add, okay? Always distribute, then add. Now, when doing these types of problems, we can either A, do it horizontally or do it vertically. Do you think I care which way you do it? No, that's completely up to you in that sense. I'll show you both ways for this one, and then from there, we'll kind of look at what you like to do, okay? Now, what are we doing with A? Are we adding or subtracting? We're adding. Why? Because there's a plus sign between the parentheses, right? Okay. So horizontally means, so we don't have to distribute anything, do we? Because it's going to be the same, right? So 2x cubed can be added with what? X cubed. Positive, right? So what's 2x cubed plus 1x cubed? 3x to the third. We stay the same, right? If I have 2 apples plus 1 apple, I have what? What's 2 apples plus 1 apple? 3 apples. Do they change to bananas? No. So the x cubes don't change. Okay. All right. Then what? We have a negative 5x squared and a positive 2x squared. So what's a negative 5x squared plus 2x squared? Negative 3x squared. All right, good. Then we have a positive x. Can a positive x be added with anything? Nope. So we write plus x, and then we have a negative 1, and that's going to stay minus 1. Now, we want to make sure these are always in standard form. Okay, from now on, since we learned standard form, I want them in standard form. Is this in standard form? Yes. Okay. What's my degree? It doesn't ask, but I'm asking. What's my degree? No. 3. A high number. Polynomial is highest 1, so 3 in this case. Yep. That's the biggest mistake people do. They want to add those. It's based off of the terms, individual terms. Okay. All right. Part B, I'm going to do this one vertically now to show you each way. What are we doing with these 2 polynomials? We are adding, right? So what I'm going to do it vertically, I'm going to rewrite the first one. So I have 3x squared plus x minus 6. And then I'm going to put the bottom one underneath, and I'm going to line them up for like terms. X squared is going to go under what? 3x squared. 4x is going to go under the x. And then 10 is going to go under the negative 6. If something doesn't have the same, we just put it off to the side, okay? And then we're going to add straight down. So what's 3x squared plus 1x squared? 4x squared. What's 1x plus 4x? 5x. And what's a negative 6 plus 10? Positive 4. Am I in standard form? Yes, so we're done. What's my degree? 2. What's my leading coefficient? 4. And what kind of polynomial is this? A trinomial. Good. Okay. So that's horizontally and vertically. Does it matter which way you do? No, you can put it away, please. All right, the difference. Okay. Now, with difference, I do like to distribute the negative first, and then you can pick which way you want. Okay. So since we're subtracting, you need to distribute that negative. So what's a negative times that positive 3x squared? Negative 3x squared. A negative and a negative make a positive x. And a negative make a positive 8. And then I'm just going to rewrite the first because I'm not distributing anything to the first, am I? No. All right. Now let's find like terms. And I'm going to do it horizontally here. Okay. If you want to do vertically, that's fine. Just line up like terms. Okay. 4x squared and negative 3x squared. So what's 4x squared minus 3x squared? X squared. Try not to put the 1 anymore. Okay, you guys know 1x squared is the same thing as x squared, right? Okay. All right, negative 3x and x. So what's a negative 3x and 1x? Negative 2x. And then we have a positive 5 and a positive 8, which makes a positive 13. Good. Are we in standard form? Yes. What's my degree? 2. What's my leading coefficient? 1, and it's a trinomial. Okay. Now, obviously, I'm just kind of refreshing through that all. All right, B. What should I do first? What are we doing in these 2? We are subtracting, right? So what should I automatically do? Distribute. So a negative and a negative is a positive 2n squared. A negative and a positive 2n is negative 2n. What's a negative and a negative 4? positive 4. Okay. Now, do you guys want to do this horizontally or vertical? Horizontally, okay. All right, so 4n squared and 2n squared. What do we get? 6n squared. Okay. Now, to keep it in standard form, what would I add next? Would I add the 5 or the negative 2n? The negative 2n. And that negative 2n, can I combine that with anything? No, so we write it as minus 2n. And then we have what? We have a positive 5 and a positive 4, which is a positive 9. Good. What's my degree? 2. Leading coefficient? 6. And it is a, I know. All right. Let's go ahead and let's do 3 and 2. So 2 and 3. Go do 2 and 3 on your own. Yep. And the only reason why they stay the same is think about, like, remember, when did we add exponents? We had x times x. What do we get? We get x squared, right? When we look at like 3x squared plus 2x squared here, we're not multiplying to get to x to the 4th, am I? We're just adding, that's why they stay the same. Okay, you're thinking about this as apples plus apples stay apples, don't they? They don't become bananas. That's how I kind of think of it. All right, I'm going to do 3 first here, because what are we doing in 3? Did you say? Yeah, so we're adding here, okay? And if we're adding, do we need to distribute anything? No. So let's go ahead and just combine. So x squared can be added with what? 7x squared. So what's 1x squared plus 7x squared? 8x squared. Good. All right, then we're going to look at the negative x and the negative x. So what's a negative 1x plus a negative 1x? Negative 2x, so minus 2. And then what do we have left? We still have a negative 2. Good. What's my degree? 2. Leading coefficient? 8, and it's a trinomial. Good. All right, and 2, what are we doing? We are subtracting, so we need to distribute. So I'm going to go ahead and rewrite the first one. All right, what's a negative and a negative 4p squared? Positive 4p squared. What's a negative and a negative p? Positive p. And what's a negative and a positive 3? Negative 3, right? Okay, so now let's combine like terms. P squared and 4p squared. So what's 1p squared plus 4p squared? 5p squared. Good. All right, what's a p plus a p? 2p. And then what's a 3 and a negative 3? 0. Do we have to put plus 0? No, we leave it, right? So this here is our final answer. What's my degree? 2. What's my leading coefficient? 5. It's a binomial. Good. All right. Is there any questions on 4.1 and 4.2? No. Pretty easy? Or not maybe easy, but actually I kind of like this kind of math. It's a little bit better than story problems and stuff. Yeah. Even though story problems are your favorites, right? All right, your guys' assignment is page 144. You have 18 through 48 multiples of 3. So that means, yeah. Yeah, go ahead. Every third problem. So 18, then 21, then 24. And then page 149, you have 9 through 54 multiples of 3. Okay, so every third problem for those. Okay.